So today we're going to be learning about fractions. Can anyone tell me what happens to a fraction that is multiplied by 1? Mitch?
Stays the same.
Stays the same. Can you give me an example?
So if I had 3/4,
Okay, 3/4.
and I multiplied that by 1/1.
So just 1.
Yeah.
Right. What does that equal?
It equals 3 4, 3/4.
Okay. So with that background knowledge that we know a number multiplied by 1 is itself, what happens when we change that number? So the 1, let's just keep it 3/4. What if we change it to 2/2? What happens then? It just doubles, right? Exactly. So we got 6, and then what do we have on the bottom? 8. Okay, cool. And then, anyone just want to simplify that real quick for us? 3/4. 3/4. Cool. Alright. Wow, look at that. All the way back here. Cool. So we have these hamburgers, right? Our fractions. And if you open them up, you'll notice that this can just be seen as 1. And then we have 2. 1/2 and 1/2. Just break those, yeah, they should just come apart real easy. So I'm going to ask you if you can find a fraction equivalent to 3/4, not using this one. Using your hamburger fraction style sets. I need to see 3 different fractions that are equivalent to 3/4. Alright, once you guys have your fractions all set up, if anyone would like to give me their examples. Yes, Jake.
9/12.
9/12. How can you prove that? How can you tell?
So I took my quarter pieces and put them on top of the 12s. And when I did that, I see that I have 3 still open, so I just subtract 12 minus 3.
So you took your quarters, right?
Yep.
Okay.
And I know that 3 of the 1/4 is equal to 3/4. And I put them over top of my 12. And when I put 3 of my quarter pieces over the 12s, there's only 3 of the 12s left. So I took 12 minus 3, which equals 9. And so that lets me see that 9/12 are covered up and by the 3/4 pieces. So 3/4 is equal to 9/12.
Very good. So we have 3. What was your numbers again?
3/4
Equals
9/12.
Cool. Does anyone have a different example that they would like to show? Mitch?
I had your 3/4, and then I had that equal to 6/8.
6/8. And how can you prove that 6/8 equals 3/4?
So I took my 3 1/4 pieces.
Yeah.
And when I place my 8 pieces on them, in order to cover up all
3 of the 1/4 pieces. I ended up using 6 of the 1/8 pieces. So then when I add all of them back together, it gave me a total of 6/8.
Beautiful. Cool. Very nice. Brian, did you have one?
They took my answers.
They took them? Okay, yeah. Alright, so now we're going to be going into the parallel tasks. Okay, so for our parallel tasks today, we have 2 choices. Number 1, 2 fractions are equivalent, for example, 1/4 and 3/12. What were they multiplied by to be equivalent? We're just going to add a little. So, and the second choice is going to be draw a picture or use your blocks. You can also use the hamburgers to show 2 equivalent fractions for 3/5. Now, once you've come up with what choice you want to do, you can then write that on a sheet of paper or on your whiteboard to display it. But I also want you to tell me how and what strategy you used to get your answers.
Okay.
All right, so who did choice number 1? Ryan?
Is it the same? I tried it. I don't know if it's right, but is it the same rule like when we're adding fractions? Whenever you have to do the bottom, that you have to keep the top?
Yeah, so what did you use to find your answer? Let's work this out. So 1/4.
Well, if you take 4,
Okay.
4 times 3 is 12. So then you have to do the same thing to the top. So it'd be times 3 again. And then 3 times 1 will be 3.
Alright. So yeah, it's just the same as adding, but once you find one, you've found the other. Because it's got to be the same, top and bottom, numerator and denominator. And for you, you guys pick choice 2 or choice 1?
2.
2? Alright, what did we come up with? So did we draw a picture, use the hamburgers? What did we do?
Hamburger.
One I used a hamburger and one I had to write out.
Okay.
So, want to do the hamburger one?
So the hamburger one that I did.
Okay.
So I took my 3/5
This.
and through kind of trial and error is kind of how I figured it out. To answer your first question. And I tried to put tenths on there, and when I covered up all 3 of my 1/5 sections with my 1/10 sections, I ended up needing 6 of them.
So you have your 1/5. You have 3 of them, correct?
Yeah, it looked kind of like that.
Like this?
Yep.
Cool. And then you lined it up with your
Tenths.
tenths. And then they were just the same.
And that's how I knew that they were equivalent to each other.
Cool. Because if there was another 1/10 or another 1/5, then that wouldn't make sense, right? Because it would be way more than what you need. Cool. All right, so let's just go back over this. So your example for how you came up with that answer was what? You related it to addition.
Yeah, finding like denominators.
Okay, and for the 3/5, oh, you didn't go over your example.
So for me, I realized that I couldn't use my fifths anymore to find an equivalent fraction and for the hamburger. So what I did is I took 3/5 and I multiplied it by 2. But when I did that, I saw that we came out with 6/10.
So you just did
Yes.
2? Okay.
And I realized that equals 6/10, which I already had. So what I did instead was did like Ryan did in his choice and did 3/3 and multiplied both and got 9/15 on the equivalent fraction.
But why does this one not work?
It does work, but
It does work,
we already had that as a choice, so, and you asked to have two equivalent fractions.
Okay, so you used this one.
And realized
your
that,
first one.
yeah, and then it came out to be the same as what I used to find the hamburger.
Mhm.
And so I, instead of using 2, I increased it and multiplied it by 3/3. And that allowed me to get a different answer, 9/15.
And like we said before, same on the bottom, same on top. Cool. So, what is one thing you guys learned today? What is a rule that you could come up with for relating it to equivalent fractions? Jake.
Like you just said, whatever we do to the bottom, we have to do on the top.
Mitch, Ryan, anyone?
I like that rule.
Yeah, it's a pretty good rule. I mean,
Good one.
what you do to the top or what you do to the bottom is essentially the same. So we could write that one down on our word map.
And that's the same thing as multiplying it by 1. Because whenever we have the numerator and denominator is the same, it's equal to a whole.
Yeah, and it just goes back to the beginning of the lesson when we talked about what happens when you multiply a number by 1.
Stays the same.
It stays the same.